Next section is transformations of functions. And so what we're looking at here is we're looking at actually two primary families of functions. We have the absolute value function, and then we have the quadratic, okay? And I've been calling them Big Papa and Big Mama respectively. And I know they look very similar, but I'm kind of drawing sloppily right now. Okay, now there's two key features. There's three. There's an A in the front, there's an H in the middle, inside the brackets, or the bars, and then there's a K on the outside of it. Now, since I have a -7 outside of the bars here, then this is a vertical shift. In fact, it's a vertical shift that is down 7. Okay, so we're going to go down 7. So we take the parent function, okay, which is 2 lines. All right, 2 lines. This is her right there. All right, her or he is going to drop all the way down to -7. All right, so every single point is going to just drop down to -7 so that she will look like this. Okay, so that's the graph of this individual right here. Now over here, it looks like we have +5 outside of the parentheses again. So, if the quadratic, the queen here, she's going to move up 5. So then we would go to 1, 2, 3, 4, 5, and then her pattern is going to stay the same. She's going to go over 1, up 1, over 2, up 4. I'm just estimating here. Over 1, up 1, over 2, up 4. So remember, that's the queen's pattern there. She moves over 1, 1, 2, 4. Okay? And then she does the same thing. She reflects on the other side. Alright, so that's number 12 would look like that. So I have number 11 is right here, and number 12 is up there. Okay? Alright, so for 13, we're going to take this whole graph and reflect across the x-axis. So, to show you how that is going to happen, I would just take everything that you see, and if you have a value up here, if it's going to reflect on the x-axis, this guy needs to change the same distance from the x-axis, but going down, all right, below it. So everything that's positive is now going to become negative. Everything that's negative will become positive. Anything that's 0 will stay 0. So we move over to 2. Are you okay, Atticus?
Yeah.
All right. Okay, so everything gets reflected below the x-axis. All right, now if you're going to cross the y-axis, this shape right here, we would actually reflect on this mirror right here. So that every value here will go over to this side. Every value here will go over to this side. This guy would come up here, up to here, and then this guy would go down there. And then once you connect the dots, you're going to get your shape. So I don't want to draw in the text in the textbook here, but it should look something like something up here. -2 will stay the same. This guy will drop down 1. This guy will stay the same. At 3, he will go up 2, and then back down to 0. So you should have something that looks like this. Okay, if you're on graph paper. Okay, so notice this guy. Right? Yeah. Whoa, whoa, whoa. Oh my gosh. Wait a second. I just oh, no. I just reflected on the x-axis. I cannot start this video over. I'm not going to do that. So, time out. Let's try that again. Because it says right here, across the y-axis, not the x-axis. That's this one. Okay? Y-axis means that this guy over here is now over here. So I'm going to draw it here. This guy that's here now goes over to there. Okay, this guy on the y-axis is here. He will stay there. Okay, the zeros will switch. This negative 2 here will go to positive 2 over here. This positive 1 here will become negative 1 over there. Okay, what else? Let's see. This guy here is here at positive 3. He will become negative 3 over there. Alright, so should have a basic shape like this. Alright, that should look like this guy flipped right over. If it doesn't look right, then something's wrong. Alright? Ooh, big mistake. Alright, so 15, describe the effect of a vertical stretch by a factor greater than 1. So it doesn't matter what the function is. If I have a vertical stretch, that means that my A value here, no matter what it is, if my A is larger than 1, then what that's going to do, it's going to have an effect on the way our graphs are actually going to tighten, okay? Because it means that the values, as soon as you have the parent function have its normal pattern, this multiplier will cause things to get bigger quicker, all right? So if you had a normal parent function like this with a 1, 1, 2, 2, 3, 3, if I put a multiplier on that, if I multiply everything by 2, when I move over 1, I'm going to go up 2. When I move over 2, I go up 4. When I move over 3, I go up 6. And so what that does is it tightens, and obviously the same thing is going to happen over here. It's going to tighten the actual value closer to the y-axis. All right. So if you could put that in your own words for number 15, that's pretty much what's going on. So we're going to use this information in 15 actually to do 17. 17 says, graph the function that is a vertical stretch by a factor of 3.5. Well, if I have a v and I need to vertically stretch it, okay, the parent function suggests that I go 1, 1, 2, 2, 3, 3. All right. Same thing on the other side. Okay. But if I'm going to do it by a factor of 3.5, that means when I go over 1, I have to go up 3.5. When I move over 2, it's going to go up 7. Okay. So this guy will definitely, and this is very rough, you'll have a graph on your test tomorrow. Alright, so this guy will definitely squeeze or tighten towards the y-axis. Alright? Now graph the function that is a horizontal translation 1 unit to the right of the parent function. So if it's 1 unit to the right, that means, okay, well, first of all, this is 16. Alright? Which means that in 17, I want this guy to actually move to the right, so that implies no change on a widening or tightening, no vertical or horizontal stretch or compression, but I will have x squared. But because I'm moving to the right, I have to stay inside the parentheses. And if I'm only moving 1 unit, then I will move to the right -1. Okay? Now you had to remember that the reason why we have x minus 1 is because if this is a 0, x has to be a number that will give you 0. And the only number that will give you 0 is a positive 1. So that's why we move over to positive 1 if we were to draw that queen. Okay? So it would look something like this on the graph, but this is just a horizontal translation to the right 1 unit. All right? We'll stop there.